freak storm causes chaos on the usually tranquil Lake Tahoe.
Not through explosions, not through tectonic collisions, but simply through weight, millions of tons of water pressing down on the Earth's crust silently, slowly, until something deep below begins to shift. Because right now at Lake Tahoe, that exact fear is starting to grow. Water levels are rising, pressure is increasing, and beneath the surface, fault lines are already there waiting. Lake Tahoe is often seen as one of the most beautiful lakes in the world. Crystal clear water, snow-covered mountains, a calm, peaceful surface that reflects the sky like a mirror. But what most people don't realize is that this lake sits in a geologically active region, a place shaped by earthquakes, a place where the ground itself has been moving for millions of years. The Tahoe Basin was formed by faulting, massive fractures in the Earth's crust that slowly pulled the land apart. These faults didn't disappear. They're still there, hidden beneath the lake and surrounding mountains, dormant perhaps, but not dead. And now something unusual is happening. Lake Tahoe's water level has surged, reaching elevations around 6,229 feet. At first, it sounds like a simple number, but in geological terms, represents something much bigger, because every extra inch of water adds weight. And when you're dealing with a lake this large, that weight becomes enormous. To understand the scale, imagine this. Lake Tahoe holds over 39 trillion gallons of water. Now imagine increasing that volume. Even slightly, that's billions of additional gallons pressing down on the Earth's surface. This pressure doesn't just sit on top, it pushes downward, into the ground, into cracks, fractures, and faults. This phenomenon has a name: reservoir-induced seismicity. It's been observed around the world, where large bodies of water, especially reservoirs, have been linked to increased seismic activity. The weight of water, combined with its ability to seep into rock layers, can reduce friction along fault lines, and when friction drops, movement becomes easier. In simple terms, water can help faults slip. Now, scientists are paying closer attention to what's happening around Lake Tahoe, because the region already contains multiple known fault systems. Some run along the edges of the basin. Others lie beneath the lake itself. Under normal conditions, these faults may remain quiet for decades, even centuries, but under increased stress, they can reactivate. This doesn't mean a massive earthquake is guaranteed, but it does mean the conditions are changing. And in geology, changing conditions matter. The increase in water levels didn't happen randomly. It's the result of heavy snowpack, intense winter storms, and rapid snowmelt. All of that water has to go somewhere, and much of it flows directly into Lake Tahoe. As the lake fills, the surrounding ground absorbs moisture, rock layers expand slightly, pressure builds, and the balance underground begins to shift. Even small changes can have significant effects. Tiny fractures can open. Microseismic activity can increase, and stress can transfer from one fault to another. Most of this happens quietly, too small for humans to feel, but not too small for instruments to detect. Seismologists monitor these subtle movements using sensitive equipment. They track vibrations, shifts, and patterns, looking for signs of change, looking for signals that something larger might be building. And in regions like Tahoe, those signals matter because the basin is not isolated. It's part of a larger tectonic system connected to the Sierra Nevada and the Basin and Range Province, an area known for stretching, faulting, and seismic activity. This means stress doesn't stay in one place. It moves, it transfers, it builds. The idea that water can influence earthquakes might sound surprising, but history shows it's possible. In multiple locations around the world, large reservoirs have been linked to increased seismic events. In some cases, even triggering earthquakes that would not have occurred otherwise. The mechanism is complex, but the concept is simple. More water, more pressure, less friction, easier movement. At Lake Tahoe, the situation is being closely watched, not because disaster is certain, but because the ingredients are there: a large body of water, active fault systems, and increasing environmental changes. Climate patterns are shifting, storms are becoming more intense. Snowmelt cycles are changing. All of this affects water levels, and in turn, geological stress. This creates a feedback loop. More storms bring more water. More water adds more pressure. More pressure increases the potential for movement. It's not immediate, it's not dramatic, but it is real. For people living around Lake Tahoe, the idea of earthquakes linked to water levels can feel unsettling, because the lake is a source of life, tourism, recreation, drinking water. But beneath that calm surface, forces are at work that most people never see. And this is what makes geology so fascinating and so unpredictable. The biggest changes often start invisibly deep underground, where pressure builds over time. Sometimes that pressure releases slowly through small tremors, minor adjustments, no damage. Other times, set releases suddenly. That's the nature of fault systems. They don't move gradually, they lock, they build tension, and then they slip. The question is not whether faults exist around Lake Tahoe. We already know they do. The question is how much stress they're under and how close they are to moving. Right now, there's no confirmation of a major event, no immediate danger. But scientists aren't ignoring the situation, because in geology, patterns matter. And when water levels rise significantly, those patterns can change. The lake itself has seen fluctuations before. Water levels have gone up and down over decades. But what makes the current situation different is the intensity and frequency of recent climate events. More extreme winters, more rapid snowmelt, more water entering the system in shorter periods of time. This isn't just about 1 year, it's about a trend. And trends are what scientists watch most closely, because trends tell a story of gradual change, accumulating pressure, and shifting balance. In the case of Lake Tahoe, that story is still unfolding. It may lead to nothing significant, minor adjustments, no major consequences, or it could contribute to a larger chain of events, a trigger, a final push. That uncertainty is what makes it important. Because even if the risk is small, impact of a major event would be significant. Earthquakes don't just affect the ground. They affect infrastructure, roads, bridges, buildings, communities. And in a region like Tahoe, where tourism and local economies depend on stability, even a moderate event could have serious consequences. That's why monitoring continues, constantly, carefully. Because understanding these processes is the only way to prepare. In the end, the story of Lake Tahoe is not just about rising water. It's about hidden connections between climate and geology, between surface and depth, between what we see and what lies beneath. A lake that appears calm, but carries immense weight. A landscape that looks stable, but is slowly shifting. And a reminder that even something as peaceful as water can have the power to move the earth, because sometimes most dangerous forces are the ones you never see coming.